Hello and welcome to the Chapter 6 Minitab lesson where we're going to talk about binomial and geometric probability distributions and how to calculate binomial and geometric distributions probabilities on Minitab. So if you have not familiarized yourself with what the binomial and geometric are, you should go and do that before beginning today's lesson because the things I'm going to be talking about won't make any sense if you're not familiar with what those two distributions are. Okay, so first we're going to start with the blood type example. If both parents carry type O and type A bloods, each of their children has a probability, or sorry, each child has a probability of 0.25 of getting two O genes and therefore having type O blood. If different children inherit independently of each other, as in each birth is independent, we want to explore the number of children out of 5 who, born to these parents, will have type O blood. So we got to ask ourselves, first of all, which distribution is this? Is this the binomial or is this the geometric? So we're going to check some of the conditions that go with using this type of distributions. The first thing I always check is there two categories? And here there clearly are, type O and not having type O blood. So we're defining a success and failure here as, because you need two options. One thing that's going to be considered your success, another thing that's going to be considered your failure to make your p-value. And the success here, I would say, would be having type O blood. So I would say yes, we're going to have our success be type O blood. And then obviously our failure would be not having that type of blood. So then the next thing I always ask myself, is there a fixed number of trials? Or, oh, sorry, I just screwed up. We want to check, are they independent? My apologies. So are the number of trials independent? Yes, we treat each birth as independent. Next up, we want to ask ourselves, is the p always the same? Sorry, I read the last one second and I shouldn't have. Just as a quick reminder, p is your probability of success. And for us, it's always the same. So we're using the same two parents every time, and therefore we always have the same probability that they have type O blood. So this would be a yes. Each child has the same chance. We'll say same probability. All right. So then the last thing we want to ask ourselves is there a fixed number of trials? Why is this one not red? Not blood. Oh my gosh. Remember, number of trials is n. This isn't really a requirement, but this alone is going to tell you whether or not you're dealing with a binomial. Remember, binomial is succeeding a certain number of times within a certain number of trials. You know your number of trials when you begin. When you're dealing with a geometric, it's repeat until you succeed. So you don't know how many trials you're going to have, you just know you're going to keep going until you succeed. So this is going to tell us whether or not we have a binomial or a geometric. You should always check this last, also just because without the other ones, you can't proceed with either distribution. So there's that. Anyway, so yes, they're only having 5 kids. Yes, there are 5 children, so n is 5, and this also tells us this is a binomial. Binomial. All right, and since we have all of these conditions fitting, we can go ahead and proceed and use the binomial distribution to calculate this. Since all 4 conditions are met, the distribution is binomial. Well, that's helpful. Alrighty, let's look at the second scenario. So we want to look at married people. This should be fun. I apologize if this second example offends you a little bit, but I was working hard to find a good example for this one, and I had a little bit of a hard time coming up with one. I'm just going to copy my questions down below. Yee. Why do I edit this while you guys are watching? So silly. Anyway, so you want to know what percentage of married people believe that their mothers of young children should not be employed outside the home. I'm hoping you read this question and think that's a little inflammatory. Anyway, you plan to interview 50 people, and for the sake of convenience, you decide to interview both the husband and the wife. Hence, you only have to interview 25 married couples. The random variable x represents the number of 50 among the 50 persons interviewed who think mothers should not be employed. This should be employed outside the home. All right. So, is there two categories? Yes, there's two distinct categories: those that think mothers should be employed outside the home, and those who don't. So, yes, we have two distinct options: a yes or a no to the interviewer's question. Okay. Now you want to ask yourself, are our trials independent? This is one where you might be thinking, oh, well, are the individuals that I'm interviewing independent? And the answer is simply no. And the reason being is that often when you marry somebody, your opinions tend to be the same on things so that you don't fight as much. This is also true that when if that's not so true for you or your spouse or anybody you know who's married, you also keep in mind that these are somebody who's these are couples that are being interviewed by a stranger, so they might not be as forthright about their opinion when it comes to disagreeing with their spouse in front of somebody they barely know. So, I don't know if know anybody like this who, tries to put on a good face for strangers and stuff like that. So, in general, spouses are not treated as independent of each other. They're usually very dependent in their opinions or having similar opinions or wildly different ones. So, really, in general, we never will treat husbands and wives as independent. And again, I'm sorry if you found this example a little offensive, but it was the best one I could find that failed one of the conditions. So, again, when we're talking about independence here, I'm talking about the mathematical definition of independence, not personal or a dictionary definition. You should be thinking like, oh, this is in terms of, what's the word I'm looking for? It's in terms of statistics, so we should be thinking, oh, so knowing one person's opinion could affect the other individual as well. That's what I'm saying about independence. Okay, let's see how Minitab can help us do some of these types of questions. So we're going to be looking at doing a geometric probability first. So we're going to be looking at the situation where we have 20 marbles, 10 are blue and 5 are white in a jar, and we want to select marbles without looking, note the color, and then replace the marble into the jar. We're interested in the number of marbles you will have to draw until you have a red marble. So this is very geometric because it's repeat, repeat, repeat until I succeed. So again, we're repeating until we get a red marble. So the first thing we're going to do is find the probability that we get a red marble on the first try. This is also known as our little p-value. So how many reds are there? Well, there are 20 out of 35. All right, and that will be, I'm going to round this 0.57143. I would suggest as you proceed through these homework exercises, you maybe don't round as much as you might think to round or what you normally do. You might be real comfortable with 2 decimal places. You should really let that go. Don't round like the devil. Ha ha ha. No, as you proceed through this, there will be some values that are very, very tiny. And because of that, it's very important that you don't round too much, because if you round too much, you'll be losing information and you'll be really far off with your estimates. Okay, so the other thing to keep in mind when you're looking at this little p is this also corresponds with an event. It's the event that I get it on the first try. And with the geometric distribution, our variable, our random variable x, represents the number of tries until we succeed. So this is also the same as the event that I succeed on the first try, or x equals 1. So the probability I succeed on the first try would be the same thing. Okay, and now what I'm going to do is I'm going to show you how to calculate that using Minitab. So this is going to be a little bit different and completely unnecessary. This is an easy event. You could have did it by hand. But here's how you do that on Minitab. We go to Calc, probability distributions, and then geometric. Oh, come on. There we go. Probability distributions, geometric. You notice the binomial's right above it. Ta-da! And here's the setup you need to pay attention to. So event probability, that's your little p, your probability of success. We're going to put that in as the 0.57143. The next thing it's going to ask you is, would you like to input a column? That's if you have your number or your x values in a column here. We do not have that. We have ours as a single constant, so we're going to click down to input constant. And this is asking you, oh, what's your number of successes? What is your equal to value that we want? We want it to be a 1. The last thing we need to do is we need to note that this is going to be a probability, a single probability, not a cumulative probability. So the difference between probability, this first one, and the cumulative probability is that cumulative means to accumulate. It means many of them at once. And this will only do a left cumulative, and I will show you exactly what that means in like part C. So if I'm just doing a single probability and equal to, or I want to do it on this trial number, we are going to be using probability. So kind of little note to self, use probability, radial dot, for equal signs. And this is very important. So you might want to make note of it. All right, I'm going to go ahead and okay, this is going to produce exactly what we expect it to. It's going to regurgitate the same number back to us. Ta-da! Okay, so why am I doing this? I want to show you how to read this a little bit more carefully. So remember, it's going to note a couple things to you. Whew, excuse me, yawn time. That was fun. All right, the first thing it reports to you is your p-value. I always double check this to make sure I didn't accidentally make a typo, in which case my results would be completely useless. And the other thing to keep in mind is it also warns you what your capital X is. It's your number of trials. It's the number of times I tried until I succeeded. And then reading this is a little weird. You kind of read it vertically. Little x is 1. So when I look for the probability that big X is equal to little x, which is 1, this is the probability result. Get the idea? Okay. So what you would report your answer is oh, when probability of x equals 1, or I get it on the first try, it would be 0.57143. Get the idea? Let's do part B. So in part B, they are asking me for, hey, instead of on the first try, how about on the 5th try? So we want to find the probability that my succeed occurs on the 5th try. And I'm going to use Minitab to do this. So I'm going to go back to Calc, probability distribution plot, back to the geometric. And then I want to input my constant as 5 now instead of 1. All my rest of my settings remain the same. This is an equal to, so I'm looking for a single probability. My event probability has stayed the same and it would through the entire problem. And now I am good to go. So this is a 5 because we are looking at doing it on the 5th trial. So we're going to go ahead and hit OK. Woohoo! So there's my answer. 0.019277.5. Alrighty, so there it is. Oh, I missed my decimal place. Sorry. Period. There we go. Cool. So that's how you use the probability version of the Calc menu for probability distribution plots. This next one you'll notice is a little bit different. Find the probability that the select number of red marbles is on the 5th try or less. So on the 5th or less. That's less than or equal to 5. Be careful with these because if it was just less than 5 tries, you'd be doing less than or equal to 4 because it would be 4 or less. Because, and this is the sad part about doing this, Minitab will only do less than or equal to's in the Calc menu. If you're wondering how you might do a greater than or something else, we'll get into that. So less than or equal to 5. So insert symbol, da. There we go. All right. So how do I do a less than or equal to? I am going to be using the cumulative probability because I'm accumulating. Normally when you would run across this, if you were doing it by hand, you do the one for 5, you do the one for 4, you do the one for 3, you do for the one for 2, you do the one for 1, you do the one for 0, and add them all up. Boy, that sounds exhausting, doesn't it? Instead, let's do less than or equal to and use the cumulative option. Okay, so I'm going to go back to Calc, probability distribution, and then up to geometric. And then instead of using probability, I'm using cumulative probability. That is the only difference. I'm still looking at 5, and my probability P, my success probability, does not change. Let's go ahead and hit OK. Woohoo! It's kind of a lot. 0.985542. So there you go. That's how you do a cumulative. So you might want to make a little note just below this. So I'm going to do it in purple because I've been doing my Minitab notes in purple this time. Use cumulative when it is a less than or equal to. And here's the sad note. That's the only ones that the Calc menu will do. It won't do a greater than, it won't do a greater than or equal to, it won't do just a plain less than. Oops, sorry. I just accidentally turned down my volume really bad. Hold on. All right. So you kind of got to be careful. So when this happens, you're going to have to like manipulate yourself into getting what you need. So since it only does a less than or equal to, if you need a greater than, you can do the complement of the event to get the greater than, or you can do other ways to manipulate this. I'm going to do some more complicated ones with the binomial. So now we're going to play a game. We're going to go down and do a binomial. Suppose Erin guesses on each question of her multiple choice 10 question quiz. If each question has 4 choices, find the probability that Erin gets exactly 1 correct on the 10 question quiz. Uh-oh. Okay, so we're counting the number she has correct out of 10. So our x value is the number that she has correct, and our probability distribution is going to be a binomial. And our binomial has success probability according to the number of options for each question, which is 1 out of 4. We're also assuming here that there are no questions where there are 2 correct answers or 3 correct answers. So there's that. Anyway, so I'm sure you've done this at some point in your life where you're like, I don't know any of the answers. I'm just going to Christmas tree it. Oh no! This sounds like a sad proposition. So we want to find the probability that she gets just 1 correct. And you can do this like we have previously. We go up to the Calc menu, we go down to probability distributions, and now we're going to choose the binomial. Now, I want a single probability because this is an equal sign. My number of trials is there are 10 questions on the quiz. My probability is 0.25 because there are 4 options, so 1 out of 4 would be the number she gets correct. And then my input constant, she wants to get 1 right. And I want you to ask yourself, how many should she get right? Is this number reasonable when you look at the answer? Ta-da! It seems kind of low. Were you expecting that? Were you expecting something pretty high? Like, oh, the probability she gets 1 right should be high. But you need to keep in mind that distributions have a certain amount of expectation along with this. So what do I mean by that? Well, what would the mean be? Let me think about this. So there's 10 options. I should get 1 in 4 option correct because, well, there's 1 in 4 chance of me getting it right, and there's 10 of them, so it should be, do 1/4 times 10. It's about 2.5. Yeah. Getting 1 correct, just 1, is actually lower than what's expected. The mean is 2.5. The expected value is 2.5. I'm just doing 10 times 1/4 or 10 times 0.25, and that's how I'm coming up with 2.5. She should get 2 correct, yeah? Or 3, or 2.5, which you can't do. So having something so low, that seems kind of like, yeah, not so great. Okay. So it's less likely that she actually gets 1 correct. Let's repeat this, but now we're going to find the probability that she gets 0 correct. And this is sort of a repeat of the previous question, so I actually think I'm going to skip this one and come back to it in a minute, because I want to show you something else. Hope that's okay with you. So the next thing is, hey, find the probability that Erin gets at most 4 questions correct in her 10 question quiz. So as you look at this, at most 4 would be the probability it's less than or equal to 4. Because 4 is an option, and it could be smaller. Now this should be a higher probability because we should expect she gets 2 or 3 correct. So this is the option she got none correct, 1 correct, 2 correct, 3 correct, or 4 correct. And we know that the mean is 2.5. So this includes the mean. It should be larger. Okay. And now I'm going to show you another way also how to do this. So we've been using the Calc menu. The other option you can use is, sorry, I accidentally touched that. Minitab also has another way to do this, and this is actually the one I prefer because I'm a little bit more of a visual person. So if you like this one, it has some pluses and minuses, just like the Calc menu, and I'll get into that in a little bit. But the other option is to use the graphical version, which is graph probability distribution plot. Then we select view probability. Sorry. Okay, let me show what that looks like. So graph probability distribution plot. And then you have these options. We are never going to use these three, so you'll get really used to I need the last one. Then we're going to click OK. And I'm going to tell it what distribution I'm dealing with. I am dealing with a binomial, not just because the question tells us that, but because that's what this looks like in its situation. So I need to change this to the binomial. This is in alphabetical order, so it's near the top. My number of trials is 10. My event probability is 0.25. So again, binomial, number of trials, 10 questions, so 10 trials. Event probability, 0.25, because you have a 1 in 4 chance of getting each question correct, and we want her to succeed. Okay, now we're going to click over to the shaded area tab. And this is where things get different. So you'll notice it has this option of probability and then X value. Hey, well, we have an X value we're interested in, not a probability. We want to know the probability, so we're going to select X value because that's the one I'm know information about and can input into here. And then it has these weird options, and these pictures are normally a little bit bigger, so I hope you can see them. Right tail, left tail, both tails, and then middle. So left tail is like I have that X or smaller. Both tails is I have that X or bigger and its negative counterpart or bigger. Let me click on the both tail one so you can see the right tail one. Right tail is that X or bigger. And then middle is in between two values. And this is the strength of the probability distribution plot version because I can also do a greater than or equal to on this using the right tail, and I can do in between two values using the middle. This is two things the Calc menu will not do. However, when it comes to doing equal tos, this sucks. I'll show you. I'll do B here in a minute using this. So this will do, I want to do less than or equal to 4, so we'd consider this a left tail, so I'm going to click left. And you'll notice when you look through your notes for some of the other examples, I'll say things like, is it a middle, is it a left, or is it a right? You'll see how this works, because I'll make a note of which one I'm using. I do tend to prefer this one over others, so, you know, at most 4 or less, so my X value is 4. We're going to hit OK, and it's a left tail because I'm doing smaller than 4. So you think about this as 4, 3, 2, 1, 0. That is all numbers on the number line that are to the left of 4, hence left tail. Let's hit OK. I love this because it also produces a cute little graph for you. So now you see what this guy kind of looks like. He's a little skewed with the 10 questions. And notice your mean does look exactly where it should be. It should be between, like, you know, right around 3. So 2 and 3. So between these two. All right. So there's 4, and notice it shaded the red area. The red area is always the area that it's doing. It always puts the X value you're interested in down below here, below the horizontal axis. And then your probability is always up above the area that you're dealing with. So area probabilities always appear above, and scores or X values always appear below. Let me put that value in here. So my answer is 0.9, oh, sorry. 0.9219. The REO goal. Yep. So that's how you do this with view probability. You also could easily do this in the Calc menu. You don't have to. You know, you're going to probably find you like one of these more than the other, and then you'll just use it a ton. You don't have to know how to use both. You just have to know how to use one effectively. So just so we're clear, the upside to the graph one is it'll do lefts, rights, and middles really easily. The downside would be that equals are actually really hard to do. Well, they're not really hard. They're a little wonky. And it also rounds quite a bit. It always does 4 decimal places. Sometimes if it's something really tiny, it'll give you something a little bit larger than 4 decimal places, but just so you're aware, it tends to round. Okay, so let's go to 0, and I'll show you how to do this. So if you're looking at this and you're like, oh, well, it does left, so it'll do area to left, it'll do area to the right. How do I do a middle? How do I do an equal to? Well, the answer is you do a middle. And it's super weird. So we're going to go to graph. Where is it? Probability distribution plot. We're going to go to view probability. I do this kind of fast because I've done it like a million times. It's kind of sad. We hit OK. I want to go to shaded area. So I want to do 0. So how do you do this? You're doing less than or equal to 0 and greater than or equal to 0 at the same time. So the things that are bigger than and smaller than 0 is just 0. And we'll hit OK. There it is. And you know you've done this correctly because it only highlights the 0 brick, the brick that represents the probability that you got 0, which is kind of funny. 0, 5, 6, 3, 1. See, it didn't round this one as much because it was small. I'm going to go ahead and do 1 also so you can see what this looks like. So we're going to go to Graph, Probability Distribution Plot, Probability View, and I'm going to put a double 1 in the shaded area. Sorry that I'm doing this kind of fast. So I want to make a point. Yes, it only shades the 1 brick because I'm greater than or equal to 1 and less than or equal to 1, and only 1 does that. So notice, compare this answer that I got from using the Calc menu to the answer using the Graph menu, and it is slightly different. It's rounded quite a bit. Well, not quite a bit, but you know, it's rounded clearly. And you also needed this correct because it only shades the brick that you wanted. And I like that visual confirmation that I've done this correctly. Sort of a personal preference. I'm going to copy this so I don't have to go find the less than or equal to sign again if I need it later. Okay, so Erin's really rocking this quiz, kind of, not at all. And she's kind of hopeful. You've given her hope by your calculations because, you know, this didn't scare her enough. The probability she's going to get like less than 40% is like 92%, which is not good. Oh, poor Erin. We've all had a day like this, though, where we're just like, I don't know what to do. Guess I'm going to try. At least she's trying, right? Anyway, so let's find the probability that she gets at least 5 questions correct on the 10-question quiz. So let's talk about what at least looks like. So 5 is the smallest option she could get. If it's at least 5, kind of like you must be at least 5 feet tall to ride this ride, you could be 5 feet tall or you could be bigger. So this is actually going the other way. So where is it? Insert, symbol, symbol. I had the wrong one. Greater than. Okay. So downside, Calc menu will not do a greater than. Wah, wah, wah. Darn. Okay. But you can do this using the probability menu, and if you monk with it a little bit, you can do it as the Calc menu option. So first I'm going to do it the graph version. So we're going to go to Graph, Probability Distribution Plot, View Probability, and here's where you need to be careful. My setup is still the same here. We're going to go to Shaded Area, and now I want greater than or equal to 5. So I want a right tail because I want things greater than or to the right of a value, and then I want to tell it I want a 5. And there we go. And we'll hit OK. And then let's just type our answer in here real quick. 0.07813. I wasn't expecting it to be that small for some reason, but, you know, I don't know. And I'd seen the picture before, so you think I'd know better, right? So just a little note, this is a right tail because you're doing it to the right. Now, I'm going to do this using the Calc menu so you can see how it's done. So this is what we want, greater than or equal to 5. But the Calc menu won't do that. It'll only do less than or equal to. So you might be thinking, what's another way I could rewrite greater than 5 so that I could be doing a less than? So I want things that are 5 or bigger. So I don't want things that are 4 or smaller. So you could rewrite this as 1 minus the probability. I screwed up. I want this guy. That x is less than or equal to 4. Sorry, which your Calc menu will do. So again, you might be thinking, oh, if this is greater than 5, shouldn't I be doing less than 5? So greater than or equal to's opposite would be a less than? Yes, but what's less than? Well, she wants 5 questions or more, so the opposite would be doing 4 questions or less. So that's why it's less than or equal to 4, not less than 5. Because again, Calc menu will not do less thans. It'll only do less than or equal to's. Same thing with the graph menu, only equal to options. So if you have a less than, you got to rewrite it as an equal to. Okay, so 1 minus the less than or equal to 4, which is 1 minus the event you literally just did a few seconds ago. I'm going to scroll up just so I can see it. 0.9219, which the Calc menu will do. 1 minus 0.9219. Oh, well, would you look at that? I used a calculator for 2 seconds while you were listening to me talk to myself. There it is. It's beautiful, right? It's the same number almost. Okay, so Last but not leastly, in our fun times with Erin, we want to know what's the probability she gets between 2 and 4 correct inclusively, so including both 2 and 4. So I want to be between 2 and 4. And I do mean the whole between thing. In between 2 and 4. And I would use the graph menu to do this again because the graph menu is the only one that will do a middle value in the middle between 2 and 4. So we're going to go up to graph, probability distribution plot, select view probability, and I want to go to shaded area. There's the middle option, and I want to go from 2 to 4. A very polite note is that notice in this tiny picture x1 is on to the left of x2, which means it's smaller than x2, and you must have your values represented as well. Your x1 value needs to be smaller than your x2 value, otherwise it will not do this. Just so you know. So you can't have this be 4 and then 2. It has to be 2 and then 4. Smaller one always on the left, just like the number line. Let's hit OK. Oh, there she is. Woohoo! Now, it's not to say you can't do this with the Calc menu. It's just a little bit more complicated. So, enter, enter. I should have written that here. Clean it up, rookie. Menu, Frenchly. Okay. So on the Calc menu, if you wanted to do this, it won't do 2 at the same time at all. So you can kind of finagle this into it. So it won't do an in-between, but it'll do to the left of 4, which would be all of these guys. And it'll do the left of 2, which would be all of these guys. So, but I really don't want that. I want between these two. So you can do to the left of 2, sorry, to the left of 4, and subtract these last 2 bricks, which would be to the left of 1 to get the in-between. So on the Calc menu, you wouldn't do the in-between. So you wouldn't do the probability that it's between, sorry, 2 and 4. You would do instead the probability that x is less than or equal to 4 and subtract from it, and now you'd pull out the Calc menu and use it a second time. The probability that our variable was less than 1 or equal to it. So I want you to look at this graph and associate what's going on here. If I want to do these in-between ones and I can only do a left, which the Calc menu will only do lefts, I do to the left of 4, which would be 4 or smaller, so that'd give me everything, all the red blocks in this blue bricks. And then to get the stuff that's just red, I'll subtract the smaller 2, the blue stuff, the 1 and the 0, by subtracting off the probability that it's 1 or less. And this will give you the same values. It's just like a roundabout way to get there. Alrighty, so that's adventures in dealing with binomials and geometrics. Keep in mind these tricks. I would say you don't have to know how to use both menus, but it might be to your benefit to use both of them because, again, the Calc menu does equal signs a little bit easier. The graph menu does in-betweens a little bit easier and lefts and rights a little bit easier, so mix and match if you like. Have a good day.